Okay, so solving exponential equations. So I'm going to tell you, when you first look at this, it looks like it's going to be really scary because you see all of this and it's a mess, right? We're going to break it down and you're going to realize it's not so difficult. It's really, it looks a whole lot worse than it is. All right, so first example, 2 to the x equals 8 to the third. And you say, I have no idea, right? Well, what if we simplify this? What if I gave you a separate example and we just said 2 to the x equals 2 to the fifth? And you'd be like, oh, well that's obvious. X has to equal 5. And I'd say that is correct. So 100% true. So the key here, what makes this a lot easier, is if the bases are the same, then we can just compare the exponents. Okay? So our whole thing today is how can I take my two values here and how can I get them to the same base? Okay, so I see 2 and 8. Well, 2 is pretty perfect, right? Well, what about 8? So 8 we know is 2 times 2 times 2, right? So 8 equals 2 times 2 times 2, or 2 to the third power, okay? So I can rewrite 8 as 2 to the third power, and then that's still raised to that original third power, okay? And then you just have to remember your exponent rules. If you have an exponent raised to another exponent, you just multiply those together. So we have 2 to the x equals 2 to the 9th, okay? And then once the bases are the same, then we just say, well, what has to be true about x? And you would say x has to equal 9, okay? And you could then put that into a calculator. Does 2 to the 9th power, does that equal 8 to the third power? And the answer is yes, it does. Okay, so that's it. So we find the same base, and then we solve for x. So what if we make this a little more difficult? So we have 9 to 2x minus the first power equals 3 times, 3 to the 6x power. Okay, so I look at my bases, 9 and 3, and I see 3 that's as simple as it's going to get, and I can rewrite 9 as 3 squared, right? So I'm just going to rewrite this. Let's pick a different color. Nice friendly blue. So we can say this is 3 squared to the 2x minus 1. And this over here, 3 to the 6x, that didn't change. Okay? It's very important here. And we don't make this mistake. And it's a very possible mistake, because I made it a couple of times, is you want to make sure the bases are the same number. Okay, notice how we have 3, that's good. So don't think of it so much as, well, I have 9 here, and if I did 3 squared, that also equals 9. So what if I'd written 3 squared to the 6x power equals 9 to the 2x minus 1, because 3 squared, that equals 9. That's all wrong. Don't do that. Okay, don't get tripped up, because notice we have 9, we have 3, those are different bases. This is bad math. Don't do bad math. Okay? I'm only saying that because I did that for this exact problem and I felt stupid afterwards. So make sure you have the same base. We have 3, we're good. All right, then we simplify our exponent on the left. So 2 times 2x minus 1 is going to simplify to 4x minus 2. We just distribute there, right? 2 times 2x minus 1. On the other side, this is already as simple as it's going to get. Okay, so not quite as straightforward as before, but I know that this exponent and this exponent have to be the same, so I can write that as its own equation. So 5x minus 2 has to equal 6x. And now we're just solving for x. So minus 4x to both sides. So negative 2 equals 2x. Divide both sides by 2, and we get x equals negative 1. Okay, I can substitute this back in. 4 times -1 is -4, minus 2 more is -6. 6 times -1 is -6. That checks out. Okay, that's it. So we change both of our bases to make sure they're the same. We take our exponents, we set them equal to each other, and then we solve for x or whatever variable we have. Okay, let's try one more. And I'll tell you, this is basically our whole week this week. So really try to get good at it today, and then the rest of the week will be nice and easy for you. Okay, so 4 to the 2n minus 1 equals 64. So there's 2 ways we could look at this one. I know 4 is 2 times 2, and 64 is 2 to the something, right? Let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, right? So I could say that's 2 to the 6th power, and then 2 times 2n minus 1. And that's one way to do it. Or we could also realize, well, I leave it as 4. 4 times 4 is 16, times 4 more is 64. So I can say this is just 4 to the 3rd power, right? And then I don't have to mess with the left-hand side. So that's a little bit easier for us to think about. So let's try that. So 4 to the 2n minus 1 equals, and this one doesn't have an exponent, it's just 64. So we just rewrite this as 4 to the 3rd, nothing to it, right? And now we just set these two equal. So 2n minus 1 equals 3. What is the value of n? So plus 1 plus 1. So 2n equals 4, or n equals 2. Let's see. 2 times 2 is 4. 4 minus 1 is 3. That checks out. Okay. So that's it. So find the same base for left and right side. Okay. Simplify your exponents as much as you can. So we're just left with a single expression on either side. Set those two expressions equal to each other. Isolate your variable, and then double check your answer, because we always check our answers in algebra class. And that's how we get 100s. All right, let's try them out. Let me know if you have any questions. Bye.